Hello everyone, welcome to the third lectures of the series Unit and Measurements. So today we will learn what are the uses of dimensions, what are its importance. We will also see what are its limitations. After that we will solve some of the important questions that are required for our board exams as well as for our competitive exams. So let's start. So basically there are three uses of dimensions. Okay, so there are three uses of dimensions. The first uses is it is used for conversions of an units. That's right, in conversions of units. So we have done this one, right, in our high school. Like the teachers used to give us for conversions of units, like from convert 5 kilometers to meters, convert 5 kg to kilograms. So this we have done. So similar things we will do today. Okay, so this is the first use of dimensions, and here we will use dimensions, right? So next the second uses is it is used to check the correctness of an equations. In the futures, if you developed a formulas, if you found a new formulas, then the dimensions of that formula should match each others. For examples, you would have the formula, right? So that formula will have left hand side and right hand sides. So that left hand side and right hand side dimensions should be equals. And the last uses is that it is used for deriving the formula also. Okay, yes, the dimensions will help us to find the formulas also. Okay, so let's write down what are the its uses. After that we will discuss one by one, and the last we will see its limitations also. Okay, so three uses of dimensions. We write it down. After that we will see one by one. The first one is for conversion of unit. Okay, conversions of units. So this is the first use. Second use is it is to check correctness of an equations. And then the third use is it is used for deriving formula, right? Yes, it helps us to find out the formulas also. Okay, so let's see this first use, how it helps us for the conversions of units. So let's see conversions of units. Conversions of unit. So now you see, whenever we represent a physical quantities, okay, whenever we write a physical quantities, it should be okay, it is always written in the form of a number and a units. Suppose if I want to represent the mass, okay, suppose that mass is how much? 5 kg. Okay, so this 5 is called the magnitude. Okay, it is called the magnitude. Magnitude means numbers. Okay, any numbers. Okay, whenever we represent any physical quantity, at the times whatever that number comes, that is the magnitude, and this obviously we know this is the units. Okay, so now these units, okay, systems are of three types. Okay, let's see what is three types. Systems are of three types. So now the first one is the, okay, units have three systems. First one is the CGS, okay, MKS. Second one is the CGS, and third one is the FPS. Okay, so MKS means what? In these systems, the unit will be always in meter, length will be in meters, and then mass will be in kilogram, and then time will be in seconds. Okay, similarly here it will be in centimeter, length will be in centimeter, mass will be in gram, and the time will be in seconds, right? Okay, next we have this one, foot. It will be in foot. with the mass will be in pound. Okay, this word pound usually I used to hear in WWE. I used to watch lots of wrestlings in my childhood days. At the times I used to hear this pound only. Okay, they used to call, the anchor used to call them that person is 500 pounds, 700 pounds. That time only I used to hear this sound. Other than that, I have not heard this systems, food, pound. Next one is the second. Okay, so these are the three systems of the units. Okay, MKS, and then you have FPS. So these are the three systems of the units. Now convergence means we have to convert from this system to this and vice versa. Okay, sometimes I have to convert from MKS to CGS, and sometimes questions they will give us to convert from CGS to MKS. Similarly with this also. Okay, now remember that the SI unit that we used, okay, the SI unit that we used is based on the MKS systems. Okay, our SI unit system is also based on this systems, right? Okay, so now we'll find a formulas to convert this, how this convergence will take place. Okay, so let's see. Okay. So let's see, suppose we have a 5,000 gram, right? So this 5,000 gram, can I write 5 kg? Yes, right? This one is in CGS, just now we did gram and kg, and this one is MKS. So now, as I said earlier, this one is the magnitude and this one is the unit. Similarly, this is the magnitude and this is the units, and these both are same. So suppose this magnitude I write as a N1 and this unit as U1. I can write it, right? So here also I can write it as this 5, right? This is a magnitude N2 and then this unit as U2. So I can write it this one, right? Next, what I can write? N1, this magnitude, let it be like this. Now this U1 is, as I said, it's in units. Now units, I have just take the example of this one as gram. Now unit may come in the form of a length also, time also, right? So I will take this unit represented as mass, length and time. So I will represent it as mass M1, L1 and T1. Okay, so M1 and then L1 and T1. These are the units. Okay, similarly this N2, this kg unit is there, this unit I will represent as M2, L2 and then T2, right? So now these all are unit only. So now unit means it have dimensions, it have powers. As remember that, okay, remember that whenever unit is converted, okay, suppose I convert gram meter cube, okay, gram cube, sorry, not gram meter cube, gram, okay, cube. If I convert into kg cube, kg, then it will remain cube only. Okay, if I convert centimeter into meter, if centimeter square I convert into meter, then it will have meter square only. So these dimensions will remain same. So dimensions will remain same means here also dimension same. Say okay, L1. So this M1 to will also have the same dimensions. Because these both are mass, right? These both are mass. So they will have the same dimension. Similarly, N1 length. So N1, if I take here B, then this will also have the B only, right? Okay, this one is B. And then T1, if I take as C, then it will also have the C. So now when I will take this one to here, then what I will get? So it will be M2 and then M2 by M1 into A and then L2 by L1 to B and then T2 by T1, dimension will be C. This formula will help us now to convert the units. Okay, this one is in kg, this one is in gram, this one is in meters, this one is in centimeters, and this one is in seconds, and this one is in seconds. Okay, so let's see if questions is given to us like this. If questions is given to us like this, suppose number A, okay, convert, suppose 5 Newton into CG. So this question is given to us. Convert 5 Newton into CGS unit. So how we will convert? Okay, so we have to use this formula. Okay, so this one is in CGS, so we need this one, right? Magnitude of CGS we do not know, we need this one. Okay, N2 is given 5 only. N2 is given how much? 5, right? Next, so okay, before putting into these formulas, we should know what are the dimensions A, B and C. Okay, what is their dimension we should know. So now let us see. Unit is Newton. Newton means force, and the dimension of force is, as I told you, you have to remember it, this one, okay, because it's coming again and again. So deriving in long, it will take times, right? And my lecture will also go for a long time, so you better remember it. So I remember it, then I can directly place like this: L1 t to the power minus 2. Okay, so M1 L1 to the power minus 2. Then here M1, M is mass only, so it have the power of 1. L for L, B power is 1, and then T have the power of C. Okay, so C is equal to how much? Minus 2. Now we can put in this formula. Okay, so let's see. Okay, yes. Now N1 is equal to N2 is equal to how much? 5. M2 is in kg. M2 is in kg. And this one is in gram, and power is how much we got? 1. And this one was in meter, and then centimeters. It has powers of 1. And similarly T2, see, T2 is in, T is in second, it was also in second, so it will be minus 2. So what we will get? 5 kg 100,000 gram by gram, power 1 only, meter 100, centimeter, here also centimeter, meter is equal to 100 centimeter, right? Power 1, and then second by second minus 2. Next, so what will get? So this will be 5 into 10 to the power 3 into this will be 10 to the power 2, right? Now don't cancel this GG, okay? Don't cancel this GG. See, because we are doing like this, right? 5,000 gram equal to 5 kg. See, now all this, if we cancel this gram and kg, then all things will be cancelled out, right? So don't cancel this units, okay? So if you have converted into gram, let it remain into gram. So G, and then centimeter, and then second square, right? Gram power 1, centimeter power 1, second squares, right? Negative squares. So it will be 5 into 10 to the power 5 gram centimeter second squares. Yes. So this is the answer. This is the convergence of MKS into CGS. Okay. Now in CGS, okay, this gram 5 into 10 to the power 5. In our MKS systems or SI units, the force unit is newtons, right? So in CGS, okay, it is called, in CGS it is called force, right? It is called dyne. Okay, it is called what? Dyne. This together gram centimeter per second squares, we can write it as dyne. Okay, this is how we convert. Okay, so now next you do, I'm going to wrap I'm going to rub this one. The board has become very hard to rub because of water maybe. Okay, so questions you do first. Question number 2, convert. Okay, convert 10 joules, 10 not you say 12 joule into CGS unit. Okay, CGS units. So what you will do first, you will see the joule. Okay, so joule, it is a unit of what? It is a unit of energy, right? Energy is the dimensions of, what is the dimensions of energy? Dimensions of energy is M1 L1 T to the power minus 2. So you derive it. and then you put it. Okay, so if I will derive it, it will take times, so lectures will be long. Okay, so convert 12 joule into CCS unit. Here N1 is equal to, we have to find N2 is equal to given 12. Now we got A is equal to 1, B is equal to 1. Okay, for energy it is L2. Okay, not L1. So C is equal to, it will be B is equal to 2 and C is equal to minus 2. Now we will put in the formula. N1 is equal to N2. So N2 is how much? 12 into M2 by M1. M2 will be in kg. This will be in gram. Power will be 1. Similarly, what we have, length 1 meter by centimeter. Power is how much? 2 now. And then time is second by second minus 2. Directly I have put in the formulas. Okay, so it will be 12. Kg means 1000 by G. Power is 1 only. Meter 100. Centimeter. So it will be second value means second only minus 2. Right? So it will be 2 into 12 into, this will be 10 to the power 3 into, this will be power 2, right? So 100 means 10 to the power 2. 100 square means it will be, what will be this? 100 square means it will be 10 to the power 4, right? It will be 100 thousands. Not 100 thousands, but 10 thousands. Okay. Yes. So next, what we have? A gram. Gram power is 1 only. Centimeter square, and then second square. Okay. So it will be 12 into 10 to the power 3 plus 4 is 7, and then gram, centimeter square, and second squares. Okay. So it will be 12 into 10 to the power 7. Now this energy, okay, it is the unit of this joule. Okay, this joule, it is the unit of energy. Okay, in MKS system or SI units. Okay, but in CGS unit it is called arc. Okay, so these terms you can write it directly arc only. Okay, you can write it arc. Okay, so this is how you do the convergence. Okay, next we will see if it is reverse. Okay, if it gives to us to convert from CGS to MKS, then how we will do? Just you reverse the formula. Okay, so let's see one, we will do one and we will see. After that we will proceed to the next. Okay, so questions is given to us now. Question 3, right? Yes. Okay, so question is given to us. Convert 75 arc into MKS unit. So now we have to convert 75 arc. Just now before I said arc is the unit of what? Energy, right? Energy only. Arc is the unit of energy only. So now what is the dimensions of energy? M1, L2, and then T to the power minus 2. Okay, arc. Okay, it is the unit of, okay, arc, as I said, arc is, it is the joule. Okay, this is the work done. Work done means what? Energy only, right? Yes. Okay, yes, arc means energy, and energy dimension is M1, L2, and to the power minus 2. Arc. Okay, it is the joule. Okay, joule means arc. It is in MKS and it is in CGS. So now, and it will reverse. Okay, the formula will be now like this. N1 is equal to, it will be like this. N2 is equal to N1 into M1 by M2 A, and then L1 by L2 into B, and then T1 by T2 into C. This one will be in gram. This is the gram. M1 was the gram, and then M2 is the kg. Now this gram we have to convert into kg. Here centimeter we have to convert into meters. Okay, this centimeters will be converted. So now here what you will get? So N1 we got 75. Okay, M1, right? M1 what we got? M1 what we got? M1 it's in a gram, and this one is in kg, right? So A, how much we got? 1. L1 is in centimeter, L2 is in meter, and then power is 2. B power is 2, right? And then next what we have? T1. T1 is how much? T1 is in second only, and then C have the power of -2, right? So 75 into this gram we have to convert into kg now. You see here. So 1 C thousands gram equal to 1 kg, right? So 10 to the power 3 gram we can write is equal to kg. This we can write 1 kg means kg only, right? So now 10 to the power 3 will go this side. G is equal to 10 to the power 3 by kg. So 10 to the power 3 will come up, then it will be 10 to the power -3 kg. So 1 gram is equal to 10 to the power -3 kg. So in place of G I can substitute at 10 -3 kg, because I have to convert from CGS to MKs, right? So G I have to convert into K, kilograms. So G in place of G I can put 10 to the power -3, okay, kg, and then this one is also in kg. So similarly meter, centimeter, it will be 100. So 100 means 10 to the power -2, right? It will be meter, and here also meter, and then power is 2, and then we have second will remain as it is because both are in second only. So what will be this? 75 into 10 to the power -3, 10 to the power -2 into 2, 10 to the power -4, and then I'll get kg, meter is square, and then second squares. So 75 into 10 to the power -7 kg, meter square into second square. So this as a whole I can write in joule. Okay, 7 into 10 to the power -7. This as a whole I can write joule. Okay, so 75 into 10 to the power -7 joule we got. So this is how you can convert any units, okay, from one system to another. So let's go to the next. The next one is to check the correctness of an equations. Okay, how you will check the correctness? So you have become a scientist now. You have derived a new formulas. So now I have to check whether the formula is true or not. Okay. So second use, right? Second use is to check the correctness of an equations. To check correctness, okay, of equations. Equations means formula only, right? Equations means formula only. Okay. So how we will check? So now if we get any formulas, okay, then that left hand side and right hand sides should have the same dimensions. Okay, it should have the same dimensions. Suppose we know that kinetic energy is equal to half into mass into velocity squares, right? So now let's see whether this equation is true or not dimensionally. Obviously we are using this, so it will be dimensionally proved, right? But we need proofs, okay, whether this one is dimensionally correct or not. So we have to see first equations, and then we have to take the left hand side. After that we will take the right hand sides, and we will see whether both the equations have the same dimensions or not. So let's take the dimensions of kinetic energy. Okay, so kinetic energy dimension is same as energy only, right? And the kinetic energy is energy only. So what is the dimensions of energy? Okay, dimensions of energy you find it out fast. Okay, yes, m1, l2 and t to the power -2, because energy formula is what? Force into displacement. Force into displacement. Force you will get m1 L1 t to the power minus 2 and then into L, right? Into L. So you will get m1 L2 and then t to the power minus 2. You will get this for the energies. Okay, you try and try. Okay, so LHS we got how much? LHS how much we got? LHS equal to kinetic energy equal to energy, and then the dimensions we got this much. So LHS of kinetic energy equal to this much. Now RHS what we have? Half of mv square, where m is mass, v is velocity. So now half is constants. Okay, half is constants. So constants we don't need. So now mass m, v means velocity. So velocity means distance by or displacement by time, and then we have square also. So what will be this? M will remain as it is into displacement means by length by time square. So what will be this? M, and then this will be L square. This will be T square. So that means M L square. Nothing means 1. T will go up. So it will be like this. So now see whether LHS equal to RHS. LHS M1 L square T to the minus 2. And similarly RHS M1 L2 and T to the power minus 2. That means both of them have the same dimensions. Okay. So LHS equal to RHS. So what happened? It is a correct. This formula is correct. Okay. So let's find it out for another formulas. Okay, and check their dimension whether it is true or not. So before that you write one point which is very important. The point is, if equation is if this point note, okay, if equation is correct, then it should be dimensionally correct. So if equation is correct, then it should be dimensionally correct. Okay, if you found the right formulas, you have become scientist now. If you found the right formulas, then you are, if dimension is correct, after doing that one also LHS equal to RHS, then your equation is correct. Okay, but sometimes what happens, dimensions may be correct, your equations may be not physically correct, it may be not applicable for the real world. This may happens. Okay, but if equation is dimensionally correct, then it is not necessary that it should be physically or practically correct. Okay, so what happens, if your equation is true, then it should be dimensionally true, but it is not necessary. Sometimes what happens that equations may be dimensionally correct. Okay, sometimes equations may be dimensionally correct, but it is practically it is sometimes not correct. Okay, so suppose examples we have this one, the impulse, impulse force into time is formula, and then similarly this one momentums have the same dimensions, but they are practically very different. Okay, so you write it down. Now we will check the correctness application of another formula. Okay, Then let's check the correctness of another formula. Okay, so that question is this one. Okay, number 1. A students propose. So this students from the new formula, okay, and he proposed. A student proposed the time period. So he did experiment with the pendulum, time period of pendulum, and time period, okay, you take it as t. Time period of pendulums, and okay, students propose the time period of pendulum as t is equal to 1 by, okay, t is equal to 1 by twice by root over m by L into G, where m is the mass of bob, L is the length of string, and then G is acceleration due to gravity. Okay, so now he have proposed these formulas, and now you are not agreeing with him, okay, but he also want to prove that this one is the correct. So now how you will prove it, whether this one is correct or not? Yes, you will check the dimensions. So you, okay, check whether it is correct or not. So you check it whether this question is correct or not. So how you will check? First you will take that, you will find out the dimensions of the left hand sides. After that you will find the dimensions of right hand sides. If the dimension is not matching, then it is not the correct equations, right? Yes, yes sir. So you check it, okay. So what you will do, LHS. So on LHS what we have, LHS equal to t only, time period, so same dimensions, right? So on the right hand side what will come, what should come? So right hand side what you have, right hand side you have 1 by 2 pi root over ml by g. Yes, now we have to rub these questions, after that only we can find. Let's see, the formula is t is equal to 2 pi mlg. So now we have to find dimensions. Dimension means this 1 by 2 pi, this dimensionless, right? So we have only this one, ml by g. Okay, so now m means mass, yes, L means it is the length of the string, right? Okay, so it will be L only. Now G means acceleration due to gravity. Okay, G means acceleration due to gravity. So A, acceleration, and G will have the same dimensions. So A is equal to what? Velocity by time. Velocity means displacement by time, and then one more t is there, right? So it will be displacement by time square. Okay, so it will be displacement is length, and then time square, when it will go up, then it will have the power of -2. This one we have done already in lectures 1. Okay, so I will have to do it again and again. So I'll directly place it here, L, and then t to the power -2. Okay, and then we have root. Yes, we have the root. So this will cancel out. T will go up, then it will have the empty squares. Right? So T will come out, then it will have the power m. So now in LHS we got T only. Here T will be read for m, right? Root m. Then LHS is unequal to RHS. So what, is this formula correct? Nope. Okay, this formula is not correct. Okay, so similarly you can find out you can check the correctness of any equations first by checking the LHS and then by checking the RHS. Yes, now we'll go to the most important ones, that is the derivations of the formula using the dimensions. Okay. Number 3, derivations of formula by using the dimensions. You write it down. Okay, derivations of formulas. So how we will derive the formulas? Okay, so to derive the formulas of any given physical quantity, first you should know on what factors the physical quantity depends upon. You should know this one first. Okay, in the questions it will be given that this physical quantity depends upon this and this. So find out the relations between them. Okay, examples like this. For example, questions will give like this. Okay, the kinetic energy. Okay, the kinetic energy of a body depends upon mass and velocity. Okay, mass and velocity. So find relations of kinetic energy with mass and velocity. So we have to find the relations between the kinetic energy and then mass and velocities. So now kinetic energy is depending upon the mass and velocities. Okay, so now we do not know anything. Okay, just you write that solutions. So kinetic energy is depending on mass. Kinetic energy is directly proportional to mass, right? The same words only. Kinetic energy is directly proportional to the mass. Now mass, it is a derived quantity. So derived quantity means it will have powers. It is a unit. So unit will have the powers, right? So let's A be its power. Okay, ma. Now kinetic energy is depending on velocity also. So let's velocity be v, and then let its power be b. Okay, this is the dimension. This is the dimensions, right? So now to remove their this proportionality, we have to put one constants. So let k be the constants, and then m a and then v b. Let us put this equations 1. Let us put this as equation 1. Next, what we can do? Right, we have to rub this one now. Next, what we can do? Okay, this also we have to write it down. Next, what we can do? Now we have to find the dimensions of this both one. So now what is the dimensions of kinetic energy? After finding the dimensions, you have to equate it. So what is the dimensions of kinetic energy? So dimensions of kinetic energy is, yes, it is the same as m1 L2 t to the power minus 2. This ones we have done multiple times. If you have not done, you do it and then you put it here. After finding the dimension of energy, you put it yes. Now k, okay, k means nothing. K doesn't have any dimensions. Constants. Mass will have the dimensions of m only, and then a. Velocity means lt minus 1 b, right? This one we know it. Velocity means what? Displacement by time. Displacement means what? L, time, right? So L will go up, L will remain here only, T will go up, then it will have the power of minus 1. I have written same one. Okay, so now what will get? MA, LB, L will have the power of B, and then T will have the power of minus B. Okay, M1, L2, T to the power minus 2. So what you have to do now? What you will do? Equate it, right? Equate it. This one we have done right in maths. Yes or no? AX, AY. If AX equal to AY, then X equal to Y. We can write. Yes, you can write. Right. So A equal to 1, then B equal to how much? 2, and this T equate it. T minus B equal to minus 2. Minus B equal to minus 2. So we get the value of A is equal to 1, B is equal to 2. Now equations 1, you see what you got? In equations 1, what you got? You can keep it here. So kinetic energy is equal to how much you got? K constant is there, and then M A how much you got? 1. V how much you got? V how much you got? B. So B is equal to 2. You see, we found the formula of kinetic energy, right? This K's value is how much? Half, right? This constants. Okay, K will have the value of half. So this is how we find the formulas, or this is how we find the dimensions. Okay, by using the dimensions we find the formulas, right? Yes sir, yes. So I want to do one more questions. Okay, we will do. So that questions is now, okay, a force, a body is moving with a force F on a circular path of radius r. Okay, radius r. Now it is found that F depends on r. Okay, depends on the radius of the circle. Okay, mass m and velocity of itself. So find relations. So find relations of F with M, V, and R. So write down the questions and pause it, and you try to do yourself. You try to do yourselves. After that, you watch it here. Right? You watch it here. Okay? Yes. Solutions. What is given? The force is directly proportional to, force is depending on what? Mass. Okay? Force is depending on mass, ma, and then force is depending on what? Velocity also. The dimensions be b, and then it's depending on radius also, r. That dimension be c. Now to remove its proportionality, F is equal to what? K. Okay, and then we have ma, bb, and then r, c. This you put it as equation 1. You put it as equation 1, right? Yes sir. So now this one you bring it here now. So now what is the dimension of force? Force dimension is m1, l1, and t to the power minus 2. Okay, this is the dimension of this force here. Now k, this k is no need. Okay, when we bring dimensions, this k doesn't have any value. M will remain as it is. A, v, velocity. That time we derived already. I'm not going to derive again and again. Yes, the b, and then I have the r. R means radius. Radius means length only, right? So L, C, right? Yes. Okay, let's M, A, L. L is 1 to the power b, and then one more is there. So it will be plus C, and then t to the power minus 2b. Yes, something very important is going on here. L1, t to the power minus 2. Now you compare it, right? Compare it. So after comparing, what you will get? Compare it now. Yes. So A, you compare it, right? So A equal to 1. LL you compare it, LL LL, what you will get? B plus C is equal to 1. And then T is minus 2B, minus 2, 2B, minus 2B. So what will be this? B is equal to, right? So what will be B is equal to? B is equal to 1. Yes. Is it correct? L is equal to B plus C. Yes, MA. So A, M1, L1, right? MA is equal to 1, L1. So B plus C is equal to 1. T. So T minus 2. And then T, how much we got? Okay. This velocity is not L to the power T minus 2, right? It is T to the power minus 1. See, we are about to do mistakes, right? Yeah, we are about to do mistakes. So minus B. Oh, so minus B. So B is equal to, so minus B is equal to minus 2. So that's why I always do slowly. Otherwise you will do make mistake like me only. So what will have the value? So B is equal to 2 only, right? So B is equal to 2. So B is equal to 2, you substitute here. So 2 plus C is equal to 1. So C is equal to how much you got? 1 minus 2. So it will be minus 1. Now substitute here. Substitute here. Right? Substitute here. Then what you will get? Equations 1. F is equal to K. M value is how much? M value is A is how much? 1. B is 2. And then R, C value is how much? Minus 1. Right? So what you will get? K M V square by R. So this is the formula of the centripetal force. See, we found out dimensionally. Right? Yes. So one questions I will give, you will do as a homework. Right? Yeah. You do as a homework. After that, we will proceed to the limitations. Okay, before we go to the limitations, we will do one questions that comes in JEE Advanced 2014. Yeah, JEE Advanced 2014. The questions is same like this only. Okay. So, okay, we will do directly that one. Okay. So, questions is something like this. Questions. Okay, JEE 2014. It comes in advance. Okay. Questions was like this. Okay. So what is the questions? Okay. So 1A, foggy night. Okay, foggy night. On a foggy night. On a foggy night, the railway engineers, on a foggy night, okay, foggy night, the railway engineer to determine distance D, he uses dimension analysis. Okay, he uses dimension analysis. So he found that distance, he found that D depends upon, he found that D depends upon, okay, intensity of the light, intensity S of the light, Okay, intensity formula is given by power by area. Okay, it's already was given in the questions. Power by area. Intensity S of the lights. Okay, intensity S of the light. Frequency FRE. Frequency F. Okay, frequency F of light and frequency F of light and density. Okay, frequency F of the light and density of fog. Okay, and density of fog. We found that okay, D is directly proportional to S 1 by n. This S means this S, same. Okay, intensity S by 1 by n. So find S1 by n. The value of n is, the question is given. So n value is number A, n is equal to 3. Number B, n is equal to minus 1 by 3. C, n is equal to minus 3, and D, n is equal to minus 1 by 3. So you can you can do it this easily if you know the dimension. Okay, just now we learned, right, how you will do. D is directly proportional to S F, and then what? Density. The density formula we know, mass by volumes. Power formula is given, power by intensity formula is given, power by area, and then frequency we know, it is the inverse of time, right? So let's solve fast. So let's solve what is given in the questions, that D is directly proportional to S, let it be A. Okay, and then we have frequency, let it power be B, and then what is there? Density, let it be A, right? Yes, and let this be equations. Okay, not let this is D to K S A F B rho A. Let this be equations 1. So now what is the dimension of distance? D. Distance means D. D means length. So length. Okay. So length. Right. The other dimensions will be what? 0. M0, L1, T0. Right. We'll get like this. And then K. S means what? Power by unit area. So you find it out here. Power by area. Power means what? Power means work done by time by area. Okay. You have to write all these questions. You write it down. Okay. After that we will do. You have to write it down. See, otherwise it will not be visible in the video. Our time is getting up. Or it's getting so much. This is my 4th time I'm making these lectures, because the time is getting so the video is getting too long. Okay, so see, S means intensity means power. Okay, power by area. Intensity means power by area. Okay, intensity is given power by area. Power means what? Work done by time, and then area is length square only, length into breadth, right? So work is energy. Work and energy are the same dimensions. Okay, M1, L2, T to the power minus 2, and then we have this one T. Okay, next we have L square. So what will be this? T will go up, so it will have the M1 and then L2, right, and then T to the power minus 3. T when will go here, T to the power minus 3, and then we have here L square, right? So this L square will get cancels. Okay, so what will have the dimension is M1 and then t to the power minus 3. M1 t to the power minus 3. Yes, power is work done by per unit time. So M1 is minus 3 and then L will get cancelled. Yes, M1 L is not there, so t to the power minus 3. So what we got? M1 L means 0 t to the power minus 3. What is this? E. Now frequency F. F means it is the inverse of time. Okay, F means it is the inverse of time. F means it is the inverse of time, right? F means what? 1 by t. It will be t inverse, right? So it will be t inverse B. And the rho means what? Density. So density means what? Mass by volume. So M, volume means length cube. When it will come up, volume means length cube. So when it will come up, M L to the power minus 3. Okay. So M L to the power minus 3. Yes, that's it. Now we can arrange it. After that, you equate it. Okay. So it will be the K no need. Okay. So you leave it. Now M, it will be the A. M is not there after that. After that, L is so this one C, right? L is equal to minus 3C. And then T, what you will get? T minus 3A minus B, right? Yes, M is equal to O. M is equal to A plus C. M is equal to A plus C. A plus M is equal to A plus C. T to the power minus, okay, T to the power minus 3A to the power minus B. Okay. And then L we have only 1 minus 3C. Okay. So now let's equate it. M0 and T to the power 0. Nothing means here 1. So what you will get? M A plus C equal to 0. So minus 3C equal to 1. Or C is equal to how much you got? 1 by 3. Okay. So if C is equal to 1 by 3, then what you will get here? If C is equal to 1 by 3, you put here. So A minus 1 by 3 is equal to 0. Then A is equal to how much we got? 1 by 3. Okay, next. So what will get then? Minus 3A minus B is equal to 0. So what will get here? A value you put minus 3. A how much we got? 1 by 3 minus B. Right? Yes. Is equal to 0. So what you will get? 3. So what will be this? So minus 1. So B is equal to minus 1 will get. Right? So A is equal to 1 by 3. So now you put it in the equations 1. Equations 1 you put it. Then what you will get? Equations 1. Equations 1 you will get D is equal to K S. A how much we got? A 1 by 3. And then F minus 1, because B value is minus 1, right? Then rho, this one is C. Okay, this one is C. Sorry. So this one is C. Okay. So what you will get? Rho C. C value how much you got? Minus 1 by 3. Now in the questions, okay. Now in the questions it was saying that D is directly proportional to S 1 by N, right? So now here also, right, what you got? If you remove this K, then this proportionality will come, right? So D is directly proportional to S 1 by N and D is directly proportional to S 1 by 3. That means D 1 by 3 and 1 by N. If you match, right, what you will get? N is equal to how much? N is equal to 3. Okay, so N is equal to 3 is the correct options. Okay, N is equal to 3 is the correct options. right? Okay, so now we will see what are the limitations of the dimensions. Okay, n is equal to 3 is the correct options. I think that options was in second options, right? First options, yes. Now see what are the dimensions or what are the limitations of the dimensions. So limitations, okay, so we will write it fast. So what are limitations? Number first, see, by this method we cannot find the value of constants. That k was there, right? That k we are not able to find the value of dimensionless constants. So can't find, can't calculate, you write can't calculate value of constant. See, this, by this method we cannot find the value of constants. Okay. Next, number B. By this methods, okay, we cannot find the formulas like that contains trigonometric, exponentials, or logarithmic terms. Okay, so it fails. Okay, can't, it can't, uh, it can't calculate the equations containing logarithmic, exponents, and trigonometric functions. Okay, so we cannot find, with this method we cannot find the formulas that have these functions. Okay, now third one, it is, it fails, so now these formulas will also be failed. Okay, by this method we cannot also find the terms that are added or subtracted. Okay, in equations, see formulas like b is equal to u plus at, so with u there is addition of at also. So by this method we cannot calculate that addition or subtracted formulas. Okay, we will get only one terms only, then another one, that one is added or subtracted terms we will not get. Okay, it fails to, okay, it fails, it is applicable here, right? It is applicable, yes, it is applicable only for the terms. Okay, only for the terms that are either multiplications, that formulas are either multiplications or they are power related. Okay, it is applicable only for the it's applicable only for the terms that are in multiplications or the multiplications or in power relations. Okay, if there is power relations, if the formulas terms are multiplicated, suppose examples y is equal to ax by cz. So for this type of questions, for this type of formulas only, this type of terms only we can find the formulas. Now if it is comes, okay, like v is equal to u plus at, then we cannot find it out. Okay, added or subtracted, if there is added or subtracted is there, then it will fails. So we will write the next limitation, that also number D. Okay, number D, will write it here. Number D, it fails for the equations that, it fails for the equations that contain added or subtracted terms. Okay, it fails if s is equal to ut plus half of at square come, then this dimension analysis is not applicable, right? So for today this much only. Study well and all the best for your preparations. Thank you. Have a nice day.